Everyone, welcome to the operating system series. Today we will learn about the operating system services. Okay, so let's continue. So first we have to know what is the operating system services. Okay, so an operating system mainly provides an environment for the execution of programs. Okay, the execution of programs. Now, it provides mainly certain services to programs and to the user of those programs. The specific services provided, of course, differ from one operating system to another, but we can identify some common classes. These operating system services are provided for the convenience of the programmer to make the programming task easier. So, one set of operating system services provides functions that are helpful to the user. So now, what type of services there are? So first of all, user interface. Okay, user interface. Almost all operating systems have a user interface, means UI, abbreviated from this is UI. So this interface can take several forms. One is CLI. CLI means what? CLI means command line interface. Okay, is command line interface. Okay, so first is command line interface. What is the use of this command line interface? It uses text commands and a method for entering them. Okay, say a program, suppose a program to allow entering and editing of comments. Okay, so you may write this way. It helps or it uses text commands and a method for entering them. That is the CLI. Okay, clear? Clear to you? Then next is batch interface, BI. Next is batch interface. Okay, in which commands and directives to control those commands are entered into the files and those files are executed. Okay, so in this and directives control those commands are entered into files, and those files are executed. Clear? Clear? And the next is, most commonly, this is the graphical user interface, GUI. Graphical user interface. Okay? Here the interface is a window system with a pointing device to direct input or output devices, choose from menus, and make selections, and a keyboard to enter text. Some systems provide two or all the three of these variations. Okay, so, and we will know about the GUI in broad aspect later. So now come to the, this is A, user interface, then B is program execution. Okay, the system must be able to load a program into memory and to run that program. The program must be able to end its execution either normally or abnormally. Okay, so you may write in this way: system must load program to memory to run program. Okay. Next, come to the part of input output devices or input output operation. Okay. Here, specific devices do specific works. Okay, like CD or DVD. Okay, DVD drive is used to record anything. Used to record. Okay, clear? Next point, you have to remember that for efficiency and protection, users usually cannot control IO devices. Okay, able to control IO devices for efficiency and protection. Therefore, the operating system must provide a means to do IO operation. Okay. Now the next, what is the next? Next is file system manipulation. File system manipulation. Manipulation. Okay. The file system is of particular interest. Obviously, programs need to read and write the files and directories. They also need to create and delete them by name, search for a given file, and list file information. Finally, some programs include some permissions, management to allow or deny the access to files or directories based on the file ownership. This is the file system manipulation. Clear? Next, come to communications. Okay, there are many circumstances in which one process needs to exchange information with another process. Such communication may occur between processes that are executing on the same computer or between processes that are executing on the different computer systems tied together by a computer network. Communications may be implemented via shared memory. Okay, implemented via shared memory or through message passing. In which packets of informations are moved between the processes by the operating system. Clear? So, come to very important part. This is the error detection. Okay. The operating system needs to be constantly aware of possible errors. Errors may occur in the CPU and memory hardware, such as memory error or a power failure. Okay, then which is may occur in CPU and memory hardware. Okay, as a memory error or power failure. Clear? In the input output devices, such as a parity error on tape, a connection failure on a network. Suppose you may write the so take this point wise. Okay, this is point number one. Point number two. In IO devices. Okay. Which type of error? Parity error, Okay, on tape. Then a connection failure on a network. Then lack of paper in the printer means underflow of paper. Okay, and in the user program also. This is under the point three, the user program. Okay, such as arithmetic overflow or an attempt to access an illegal memory location. Illegal location or or to great use of CPU time. Okay. For each type of error, the operating system should take the appropriate action to ensure correct and consistent computing. Debugging facilities can greatly enhance the users and programmers' abilities to use the system efficiently. Okay. Another set of operating system functions exists not for helping the user, but rather for ensuring the efficient operation of the system itself. Systems with multiple users can gain efficiency by sharing the computer resources among the users. Okay, so next part is the resource allocation. When there are multiple users or multiple jobs running at the same time, resources must be allocated to each of them. Many different types of resources are managed by the operating system, some such as CPU cycles, main memory, suppose many types of resources such as CPU cycle, okay, then main memory, file storage, may have special allocation code, whereas others, such as input output devices, may have much more general request and release code. For instance, in determining how best to use the CPU, operating systems have CPU scheduling routines that take into account the speed of the CPU, the jobs that must be executed, the number of registers available, and other factors. There may also be routines to allocate printers, modems, USB storage devices, or sorry, USB storage drives, and other peripheral devices. Okay. Next part is accounting. So we want to keep track of which users use how much and what kinds of computer resources. This record keeping may be used for accounting so that users can be billed, or simply for accumulating usage statistics. Usage statistics may be a valuable tool for researchers who wish to reconfigure the system to improve the computing services. Okay, and the last part is, and very much important, it is primary key, that is protection and security. Okay, protection and security. The owners of information stored in a multi-user or network computer system may want to control the use of that information. So when several separate processes execute concurrently, it should not be possible for one process to interfere with the others or with the operating system itself. Protection involves ensuring that all access to system resources in controlled security of this system from outsiders is also important, but such security starts with requiring each user to authenticate himself or herself to the system, usually by means of a password, okay, to gain the access to system resources. And it extends to defending external IO devices, including modems and network adapters, from invalid access attempts, and to recording all such connections for detection of break-ins. Now, if a system is to be protected and secure, precautions must be intuited throughout it. A chain is only as strong as its weakest link. Okay, so protection and security is much valid part for operating system services. So these are the main nine operating system services. So that's all for today's session. In the next day, we will learn about the user operating system interface. Okay, so thanks for watching this video. Do like, share, and subscribe as much as possible for getting such wonderful tutorials. Okay, bye.